Good evening, students. Welcome back. So today we are starting new chapter, work. What is the chapter? Work. What is the chapter? Work. Work is said to be done whenever a force acts on a body and the body moves through some distance in the direction of force. So, when we say work is said to be done, when we apply a force on a body, but just by applying force, we can't say work is done. After the application of force, if the body moves in the direction of applied force, then we say work is said to be done. Work is said to be done whenever a force acts on a body and the body moves through some distance in the direction of force. Thus, work is done on a body only if the following conditions are satisfied. There should be what? A force acting on a body. Then what? Point of application of the force moves in the direction of force. Where the point in which you are applying force has to move in the direction of force. See, I am holding this paper. I am applying a force here. If the paper is not moving in the direction of applied force, then there is no work done. By simply applying a force, we can't say work is done. Work is done only when the body moves in the direction of applied force. Work equal to component of force along the displacement with the displacement. Why? Listen, this need to be explained. Suppose there is a box. I am applying a force in this direction, making an angle theta with the horizontal, then this will be what? F cos theta, and this is what? Displacement S. See, I am applying a force, this box is moving in this direction, so this displacement is shown as S, and the applied force makes an angle theta with the horizontal. So what is this component? F cos theta. So what is work done? It's a product of, what is F cos theta? Component of force. What is F cos theta? Component of force in the direction of displacement. Component of force in the direction of displacement. That is F cos theta. Work done equal to F cos theta into S. So work done is equal to what? Fs cos theta. This is the equation for work done. Fs cos theta. We know that A vector dot B vector is what? AB cos theta. So what is Fs cos theta? F vector dot S vector. F vector dot S vector is equal to what? Fs cos theta. Work is a scalar quantity. Any doubt? മക്കളെ ഡൗട്ട് ഉണ്ടോ? ഇപ്പൊ വർക്ക് ഡൺ എന്ന് പറഞ്ഞാൽ എന്താ? വർക്ക് ഡൺ രണ്ടുപേരുടെ പ്രൊഡക്റ്റാ. ആരുടെയൊക്കെ? ഫോഴ്സിന്റെ ഡിസ്പ്ലേസ്മെന്റ് ഡയറക്ഷനിലുള്ള കമ്പോണന്റും ഡിസ്പ്ലേസ്മെന്റും തമ്മിലുള്ള പ്രൊഡക്റ്റ് ആണ് വർക്ക് ഡൺ. പക്ഷെ പറഞ്ഞ ശ്രദ്ധിക്കുക, ഇറ്റ്സ് എ പ്രൊഡക്റ്റ് ഓഫ് component of force in the direction of displacement with the displacement. So here, even though I am applying a force F, only the cos component of force is available for work done. The sin component is not contributing for the work done, because only the cos component acts in the direction of displacement. So what is work done? It is a product of component of force in the direction of displacement with the displacement. Note it down. Note ചെയ്യാട്ടോ. മനസ്സിലായോ? നോട്ട് ചെയ്യാട്ടോ. നോട്ട് ചെയ്യട്ടോ. വർക്ക് ഡൺ എന്ത് ക്വാണ്ടിറ്റിയാ? സ്കെയിലാർ ക്വാണ്ടിറ്റിയാ. വാട്ട് ഈസ് എ യൂണിറ്റ് ഓഫ് വർക്ക് ഡൺ? ജൂൾ ആണ് കേട്ടോ, മറക്കല്ലേ. യൂണിറ്റ് ഓഫ് വർക്ക് ഡൺ ഈസ് ജൂൾ. നോട്ട് ചെയ്യട്ടോ. നോട്ട് ചെയ്ത് കഴിഞ്ഞാ? നോട്ട് ചെയ്ത് കഴിഞ്ഞാ? നോട്ട്. നെക്സ്റ്റ്, different types of work done. Positive work done. Suppose if the displacement is in the direction of force, if force and displacement act in the same direction, see, I am pushing this paper in this direction. Paper moves in the same direction. That means what? Force and displacement are in the same direction. Then such work done is called what? Positive work done. Work done equal to F vector dot S vector Fs cos theta. Theta is what? 0. Why theta 0? Because force and displacement are in the same direction. Then we can say it is positive work done. For example, there is a box. I am applying force in this direction. Displacement is also in the same direction. So what is theta? 0. What is cos 0? 1. So what is this work done? Positive work done. Please note down positive work done. Note down positive work done. Note the positive work done. Next is what? Negative work done. If the displacement is opposite to the direction of force, work done by the force is said to be negative. For example, there is a box lying on a table. See, it is displaced in this direction. What will be the frictional force? Frictional force. Friction കാരണം ഉണ്ടാവുന്ന force. Frictional force. F suffix F, which stands for frictional force. Frictional force always opposes the motion. So frictional force is in the opposite direction of displacement. So what is the angle between displacement and the frictional force? Theta equal to 180 degree. Cos 180 is equal to what? Minus 1. So work done is equal to what? Fs into Fs cos theta, Fs cos 180. Cos 180 is equal to minus 1. So work done is equal to what? Minus Fs. What is this? Negative work done. This is what? Negative work done. When the force and displacement are in the opposite direction, we call it as what? Negative work done. Note ചെയ്യട്ടാ negative work done. Note ചെയ്യുക negative work done. Under what condition we get negative work done? When the force and displacement are in the opposite direction, we get what? Negative work done. Next is what? Zero work done. If the displacement is perpendicular to the force, see, I am taking this remote, placing this remote on my head. So I am applying force in the vertical direction and I am walking like this. What happens? Force is in the upward direction, displacement is in this direction. So what is the angle theta between force and displacement? 90 degrees. So what will be the work done? Zero. If the displacement is perpendicular to the force, work done by the force is 0. Theta equal to 90 degree. Work done equal to F vector dot S vector, Fs cos theta. What is this case? This is force and this is displacement. See here, force and displacement are perpendicular to each other. Theta equal to 90 degree. Work done is equal to what? 0. Work done is equal to what? 0. Note it down. Negative, sorry, 0 work done. So with this we can understand that work done by a head load worker. Head load worker എന്ന് പറഞ്ഞാൽ തലച്ചുമടായിട്ട് നടക്കുന്ന ആള്, പോർട്ടർ, കൂലി, അവരൊക്കെ വർക്ക് ഡൺ എത്രയാ? 0 ആണ്. Why? Because force and displacement are perpendicular to each other. Because force and displacement are perpendicular to each other. So that was about 0 work done. Next, what is the work done by centripetal force? See, direction of centripetal force is always towards the center. See, the direction of this is center. So centripetal force's direction is towards the center. This is the displacement. So angle between centripetal force and displacement is what? 90 degree. So work done by centripetal force is what? 0. And so work done by centripetal force is what? 0. Work done by centripetal force is what? 0. Work done by centripetal force is what? 0. Now you can expect certain question. Suppose there is sun and earth is revolving around the sun. Now the centripetal force is what? Towards the center, that is sun, and this is the displacement. So what is the work done by the earth in revolving around the sun? 0. And in the case of atom, at the center there is a nucleus and electron is revolving in circular orbit. So what is the angle between displacement? This is the centripetal force, this is electron. Direction of displacement is along the tangent. So this is the centripetal force. Centripetal force and displacement are perpendicular to each other. So work done by what? Electron in revolving around the nucleus is also 0. Work done by the centripetal force is what? 0. Done. So ഇലക്ട്രോണിന് ന്യൂക്ലിയസ് ചുറ്റും കറങ്ങാൻ വർക്ക് ഡൺ ആവശ്യമില്ല. എർത്തിന് സണ്ണിന് ചുറ്റും കറങ്ങാൻ വർക്ക് ഡൺ ആവശ്യമില്ല. മൂണിന് എർത്തിന് ചുറ്റും കറങ്ങാനും വർക്ക് ഡൺ ആവശ്യമില്ല. എന്താ കാരണം? ഇവിടെ ഒക്കെ ഫോഴ്സും ഡിസ്പ്ലേസ്മെന്റ് നമ്മളെ ആംഗിൾ എത്രയാ? 90. കോസ് 90 എത്രയാ? 0. അപ്പോൾ വർക്ക് ഡൺ എത്രയാ? 0. Next, force is given for acting on a body produces a displacement of F vector is equal to 3 I cap plus 4 j cap minus 5 k cap. D vector equal to 5 I cap plus 4 j cap minus 3 k cap. Then find the work done by the force. What is work done? Dot product, which we have already discussed. How to find out dot product? Fx, x component of force into x component of displacement plus y component of force into y component of displacement plus z component of force into z component of displacement. So how to multiply? 3 into 5, 15, 4 into 4, 16, minus 5 into minus 3 plus 15. What is the answer? 46 joule. This is the answer for work done. So we are doing an example for work done. If force and displacement if force and displacement are given in vector form, this should be the way to find out work done. Generally, if force is 10 Newton and displacement is 5 meter, what is the work done? 10 into 5. But if it is given as vectors, then you have to find out dot product. How to find out dot product? Multiply the x component of force and displacement, multiply the y component of force and displacement, multiply the z component of force and displacement. That is a method to find out dot product. Please do it. See it up. Note it down. Force and displacement. Work done equal to force vector dot displacement vector. Next, a body constrained to move along the z-axis of a coordinate system is subjected to a constant force given by F vector is equal to what? F vector equal to minus I cap plus 2j cap plus 3k cap. What is the work done in moving the body 4 meter along z-axis? So, displacement is only along z-axis. So, what is the I component of displacement or x direction component? 0 I cap. What is the y direction? 0 j cap. What is the z direction? 4 k cap. So, what is F vector dot S vector? 0, minus 1 into 0. Here, what is the coefficient of j? 2 into 0 plus what? 3 into 4. So, what is F vector dot S vector? 12 joule. Any doubt? Doubt now? Doubt now? We discussed dot product. We have discussed the dot product in motion in a plane chapter in detail. Note here. Note data. So that is also done. Next. A man tries to pull a rigid wall for a long time but fails to displace it. What is external work done by him? മാഷ് ഒരു ചുമരുമെന്ന് കുറെ നേരം തള്ളുക, പുഷ് ചെയ്യുക, പക്ഷെ ചുമര് നീങ്ങണില്ല. അപ്പൊ വർക്ക് ഡൺ എത്രയാ? ആൻസർ എത്രയാ? 0 ആണ്. കാരണം ഫോഴ്സ് അപ്ലൈ ചെയ്തുകൊണ്ട് വർക്ക് ഡൺ ഉണ്ടാവില്ല. ഫോഴ്സും വേണം, ഡിസ്പ്ലേസ്മെന്റ് വേണം. റിജിഡ് വോളുമ്പോ കുറെ നേരം പുഷ് ചെയ്ത് കഴിഞ്ഞാൽ ഫോഴ്സ് ഉണ്ട്, പക്ഷെ എന്തില്ല? ഡിസ്പ്ലേസ്മെന്റ് ഇല്ല. Suggest two conditions for the work done by a force to be 0. എപ്പോഴൊക്കെയാണ് വർക്ക് ഡൺ ബൈ എ ഫോഴ്സ് 0 ആവുക? അതെപ്പോഴൊക്കെ വെച്ച് കഴിഞ്ഞാൽ when theta is equal to 90 degree, when force and displacement are perpendicular to each other, ഒരു കണ്ടീഷൻ. പിന്നെന്താ? when there is no displacement. The first case, when theta equal to 90 degree, work done will be 0. when one of the vector is 0, അതായത് ഫോഴ്സ് ഇല്ല അല്ലെങ്കിൽ ഡിസ്പ്ലേസ്മെന്റ് ഇല്ല, വർക്ക് ഡൺ വിൽ ബി 0. നോട്ട് ചെയ്യുക കേട്ടോ. ഫോഴ്സും ഡിസ്പ്ലേസ്മെന്റും പെർപെൻഡിക്കുലർ ആകുമ്പോൾ വർക്ക് ഡൺ 0. പിന്നെന്താ? ഫോഴ്സോ അല്ലെങ്കിൽ ഡിസ്പ്ലേസ്മെന്റോ 0 ആകുമ്പോൾ വർക്ക് ഡൺ 0. Done? ഡൗട്ട് ഉണ്ടോ? നമ്മുടെ ചാപ്റ്ററിന്റെ പേരുന്ന വർക്ക് എനർജി പവർ. വാട്ട് ഈസ് വർക്ക് ഡൺ? ഫോഴ്സ് വെക്ടർ ഡോട്ട് ഡിസ്പ്ലേസ്മെന്റ് വെക്ടർ. Here we were seeing different types of work done: positive work done, negative work done, zero work done. So next topic, work energy theorem. Let me tell you, ഇത് വളരെ ഇമ്പോർട്ടന്റ് ആണ് കേട്ടോ. വർക്ക് എനർജി തിയറം വളരെ ഇമ്പോർട്ടന്റ് ആണ്. വർക്ക് എനർജി തിയറം. It says that work done by the net force acting on a body is equal to the change produced in the kinetic energy of the body. Work energy theorem is very simple. What is work energy theorem? Work done എന്ന് പറയുന്നത് ചേഞ്ചിങ് ആൻഡ് എനർജിയാണ്. എന്താ വർക്ക് എനർജി തിയറം പറയണേ? വർക്ക് ഡൺ എന്ന് പറയുന്നത് എന്താ? ചേഞ്ചിങ് ആൻഡ് എനർജിയാണ്. It says that work done by the net force acting on a body is equal to what? Change produced in the kinetic energy of the body. Proof. Suppose a constant force F acting on a body of mass M produces acceleration A in it. After covering a distance S, suppose the velocity of the body changes from, നമുക്ക് നോക്കാം. We know that V square equal to what? U square plus 2AS. Newton third law. Let this be equation 1. I am multiplying equation 1 into half M. So, half mv square is equal to half mu square plus half m into 2as. So 2 gone. Half mv square minus half mu square is equal to mas. We know that force equal to ma. So half mv square minus half mu square is equal to fs. We know that work done equal to fs. So half mv square, half mv square is what? Final kinetic energy. Half mu square is what? Initial kinetic energy. So final kinetic energy minus initial kinetic energy is equal to work done. That means what? Changing kinetic energy is equal to work done. This is the work energy theorem. So what is work energy? The theorem, changing kinetic energy is equal to work done. വളരെ important ആണ്. എന്താണ് വർക്ക് എനർജി തിയറം പറയുന്നത്? വർക്ക് ഡൺ എന്ന് പറയുന്നത് ചേഞ്ചിങ് കൈനറ്റിക് എനർജി ആണ്. അതാണ് വർക്ക് എനർജി തിയറം പറയണേ. നോട്ട് ചെയ്യുക, വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. നോട്ട് ചെയ്യേണ്ട വർക്ക് എനർജി തിയറം വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. ഇതുവരെ എടുത്തതിൽ വെച്ചിട്ട് ഏറ്റവും ഇമ്പോർട്ടൻ്റ് വർക്ക് എനർജി തിയറാണ്. അത് എപ്പോഴും പരീക്ഷയ്ക്ക് ചോദിക്കുന്നതാണ്. നോട്ട് ചെയ്ത് കഴിഞ്ഞാൽ എല്ലാവരും നോട്ട് ചെയ്താ? അപ്പോൾ വർക്ക് ഡൺ എന്ന് പറഞ്ഞാൽ എന്താ? ചേഞ്ചിങ് കൈനറ്റിക് എനർജി കേട്ടോ. അടുത്തത് How can you find the work done from the force displacement graph? ശ്രദ്ധിക്കുക, area of force displacement graph gives work done. ഫോഴ്സ് ഡിസ്പ്ലേസ്മെന്റ് ഗ്രാഫിന്റെ ഏരിയ നമുക്ക് എന്ത് തരും? വർക്ക് ഡൺ തരും. മക്കളെ മറക്കല്ലേ, ഏരിയ അണ്ടർ ഫോഴ്സ് ഡിസ്പ്ലേസ്മെന്റ് ഗ്രാഫ് ഗീവ്സ് വാട്ട്? വർക്ക് ഡൺ. ഏരിയ അണ്ടർ ഫോഴ്സ് ഡിസ്പ്ലേസ്മെന്റ് ഗ്രാഫ് ഗീവ്സ് വാട്ട്? വർക്ക് ഡൺ. മറക്കല്ലേ, ഏരിയ അണ്ടർ ഫോഴ്സ് ഡിസ്പ്ലേസ്മെന്റ് ഗ്രാഫ് ഗീവ്സ് വർക്ക് ഡൺ. നോട്ട് ചെയ്യുക കേട്ടോ. ഫോഴ്സ് ഡിസ്പ്ലേസ്മെന്റ് ഗ്രാഫിന്റെ ഏരിയ നമുക്ക് എന്ത് തരും? വർക്ക് ഡൺ തരും. Note down, area under force displacement graph gives work done. Area under force displacement graph gives work done. Area under force displacement graph gives work done. Note here, area under force displacement graph gives what? Work done. Next here. Calculate the work done in lifting a body of mass 10 kilogram to a height of 10 meter above the ground. Suppose there is a mass 10 kilogram. We are lifting the body to a height 10 meter above the ground. What is the work done? Force into displacement. What is the force here? Gravitational force mg. So what is work done? Mg to a height, displacement can be written as what? H. So work done is what? mgh. That is mass is what? 10. Gravity 9.8 into height is what? 10. 100 into 9.8. So what is work done? 980 joule. What is work done? 980 joule. നോട്ട് ചെയ്യാം കേട്ടോ. Any doubts? Noted. Okay. Next problem. Work done by a variable force. Listen, this is very tricky one, very important also. See, earlier we had seen a fixed force of 10 Newton. Suppose, imagine a situation, I am placing this remote on my hand. Initially, I am applying a large force, then slow force, then again large force. I am applying force of different magnitude. So that is the reason why it is heading is what? Work done by variable force. Here, displacement is what? X, and frictional force is what? F. See, I am dividing the whole displacement into small intervals, and in a very small interval I can almost consider this force as a constant. See, in this very small displacement നമ്മൾ പലതരം ഫോഴ്സ് ആണ് അപ്ലൈ ചെയ്യുന്നതെങ്കിലും ഈ സ്മോൾ ഡിസ്പ്ലേസ്മെന്റ് ഡി എക്സിൽ അല്ലെങ്കിൽ ഡെൽറ്റ എക്സിൽ ഐ ക്യാൻ കൺസിഡർ ദിസ് ഫോഴ്സ് ആസ് എ കോൺസ്റ്റന്റ്. This force is what? A constant. So it will be area under this. Area is equal to f of x dx. Why f of x? F of x means force only. That is force thaneyanu. But still I am writing f. Why I am writing f of x? Because it depends on displacement. Because every position depends on position, not displacement. It depends on position. Every position, what happens? Force changes. So force is a function of position x. So what is the small work done dw? F of x dx. This is the small work done. Therefore, the total work done w is equal to what? Integral dw. Total work done is equal to integral initial position xi to final position xf f of x dx. This is the total work done. Initial position xi to final position xf f of x dx. This is the work done by variable force. What is xi? Initial position. What is xf? See, this is the final position xf. This is the work done by variable force. Listen, when you should apply this concept? When the applied force is not a constant. When the applied force varies with the position, you should use this equation for work done. What is that? Integral xi to xf f of x dx. ഇത് ഇമ്പോർട്ടൻ്റ് ആണ് കേട്ടോ, വർക്ക് ഡൺ ബൈ വേരിയബിൾ ഫോഴ്സ്. Once more explain ചെയ്യാൻ പറ്റും. Okay, thank you. See, I'm explaining one more time. This is the position x. This is the applied force. See, here force varies with the position. Force is not a constant. So why I have drawn a graph like this? Because force is not a fixed force. It is varying force. Now I am making the total force into different forces in very small position. So this is the initial position xi and this is the final position xf. Xi initial position is final position xf. So see, this curve is what? Force. Force is not fixed, it is varying. But for a small time interval, for a small position, if you consider this small position, the force is almost a constant. I am making this as constant. So what will be area? Area is equal to f of x dx. What is this dx? Small change in position. During this small change in position, force is a constant. So what is work done? Small work done. dw is equal to f of x dx. This is a small work done in moving this body through small change in position dx. And the force is what? F of x. What will be the total work done? Total work done equal to integral dw, initial position xi to final position xf. So integral xi to xf f of x dx. So work done, what is the total work done for a variable force xi to xf f of x dx? Please note it down. Note ചെയ്യാം കേട്ടോ. മനസ്സിലായോ? Yeah, energy of a body is defined as its capacity or ability to do work. The energy of a body is measured by the amount of work the body can perform. How much work a body can perform is called energy. Energy is a scalar quantity. Dimensional formula of energy is what? Same as that of work done. Energy is measured in the same unit as that of work. SI unit of energy is what? Joule. Please note down energy. Energy is the capacity or ability to do work. It is the amount of work a body can perform. Energy is a scalar quantity. Dimensional formula ml square t raised to minus 2. Energy is measured in the same unit as that of work done. SI unit of energy, joule. Note it down, energy. All of you noted, right? Next, mechanical energy. Energy produced by mechanical means is called mechanical energy. It has two forms. Kinetic energy. What is the equation of kinetic energy? Half mv square. And potential energy equation is what? U is equal to mgh. Energy possessed by, yeah, note down mechanical energy. Energy produced by mechanical means is called what? Mechanical energy divided into two. What are they? Kinetic energy and potential energy. Kinetic energy half m square, potential energy mgh. Then mechanical energy done. Next, kinetic energy. Energy possessed by a body by virtue of its motion is called its kinetic energy. Kinetic energy equation is what? Half mv square. Unit is what? Joule. Energy possessed by a body by virtue of its motion is called kinetic energy. Expression for kinetic energy. Consider a body of mass m which is initially at rest. When a force is applied, it gets an acceleration a and its velocity increases to v while traveling the distance s. So initial velocity is what? U. When a force is applied, its velocity increases to what? V and its acceleration is what? A. Here body starts from rest. So what is the initial velocity? Equation is what? V square equal to u square plus 2as. Initial velocity is what? 0. So V square equal to what? 2as. So S is equal to what? V square by 2a. Work done is equal to what? F vector dot S vector. Okay. That is work done equal to what? Fs. So work done is equal to, instead of F we can write what? Ma. Instead of S we can write what? V square by 2a. So a gone. So work done is equal to what? Half mv square. This work done is stored as what? Kinetic energy. So kinetic energy is equal to what? Half mv square. So this is the expression for kinetic energy. Expression for kinetic energy. How we are getting kinetic energy? Note ചെയ്താ? So we are done with the kinetic energy. Relation between kinetic energy and linear momentum. This relation is very, very important. I am doing it one more time. Momentum P equal to mass into velocity. Kinetic energy is equal to half mv square. I am multiplying the equation of kinetic energy with m by m. So kinetic energy becomes what? M square v square by 2m. So momentum P equal to mass into velocity. P square equal to what? M square v square. So kinetic energy is equal to what? P square by 2m. So P square equal to what? 2mk. P equal to what? Root 2mk. So what is momentum? P equal to root 2mk. What is the relation between kinetic energy and linear momentum? P equal to root 2mk. Makkale, this is important. This is very important. You can expect problems based on this. P equal to root 2mk. Relation between kinetic energy and linear momentum. This is very, very important. Done, finish. Okay, P equal to root 2 mk. Next, potential energy. Energy possessed by a body by virtue of its position. By virtue of its motion, kinetic energy, position, potential energy, or state of strain. State of strain എന്ന് പറഞ്ഞാൽ ഇങ്ങനെ വലിഞ്ഞിരിക്കുന്ന അവസ്ഥ. You know, bow and arrow, right? If arrow is in the strained position, it will have potential energy. When you release the arrow, it becomes kinetic energy. Is called its potential energy. Expression to find gravitational potential energy near the surface of the earth. Work done to lift a body to a height h from the surface of the earth is given by what? Work done equal to force into displacement. If the body has mass m, what will be the gravitational force mg into displacement is what? Height h, work done equal to mgh. This work done is appeared as what? Gravitational potential energy. So what is equation for potential energy? mgh. This work done is appear as what? Potential energy, gravitational potential energy. What is equation? mgh. What is equation? mgh. What is equation? mgh. Note down gravitational potential energy or potential energy equation mgh. Then next is a very important point which I do it separately. Prove that the total mechanical energy remains constant when a body is dropped from a height. Total mechanical energy remains when a body is dropped from a height. Let's see. First one, position A, position B, position C. See, this is the height h and C is the ground position. A body is getting dropped from point A. So when it is dropped, initial velocity is what? 0. And let this distance be, point B distance be at a distance what? Point B be at a distance The distance between A and B is x. So distance between B and C is what? H minus x. The whole distance is what? H. The whole distance is what? H. Distance between A and point B is what? X. Distance between B and point C is what? H minus x. Now let's see. At position A. At position A. See, I am dropping my pen from position A. I am dropping my pen from position A. I am dropping my pen from position A. At position A, initial velocity is what? 0. So kinetic energy is what? Half mu square. Initial velocity is 0. Kinetic energy is what? 0. But what is potential energy? mgh. Because it is at a height h. So what is total mechanical energy? E is equal to kinetic energy plus potential energy. So E is equal to 0 plus mgh. So total mechanical energy equal to what? mgh. The total mechanical energy at position A. At position B. At position B, what happens? After dropping the pen from this height, at the position B, it has traveled a distance x. So initial velocity is what? V square equal to what? U square plus 2as. So half mv square equal to half mu square plus what? Half m into x. So before that, it's not required. Here u is what? 0. A is what? G. Displacement is what? When I drop the pen from this point up to B, means at the position B, how much distance it has traveled? X. So displacement equal to x. So V square equal to 2gx. Kinetic energy K equal to half mv square. So half m into 2gx. So what is the kinetic energy? mgx. What is potential energy? See, potential energy is always calculated from the ground height, not from the top. So what is the potential energy height? H minus x. So potential energy is what? mg into h minus x. Why mg and h minus x? Because from the ground level, the position B is at a height of h minus x. So potential energy is equal to mgh minus mgx. So what is total energy? K plus U. What is K? mgx plus potential energy is what? mgh minus mgx. So mgx got cancelled. So total energy, again we got the same answer, mgh. Any doubt? Now what happens at the position C? At the position C, potential energy is what? 0. Kinetic energy is equal to what? Half mv square is equal to what? Half m into, okay, I will explain in detail. So v square equal to what? U square plus 2as. Since body dropped from a height, initial velocity is 0. A equal to g, displacement is equal to h. So v square equal to 2gh. V square equal to what? 2gh. So kinetic energy is equal to what? Half mv square. So half m into 2gh. So again 2 gone. Kinetic energy is equal to what? mgh. Total energy is equal to kinetic energy plus potential energy. Kinetic energy, total energy is equal to mgh. Potential energy is what? 0. So my understanding is what? At all three positions, total mechanical energy is what? Remains constant and its value is what? mgh. So when you drop a body from a height h, the total mechanical energy remains what? Constant. When a body is dropped from a height, Total mechanical energy remains what? Constant. Any doubt? A doubt ഉണ്ടോ? Total mechanical energy remains constant when a body dropped from a height. ഇത് വളരെ ഇമ്പോർട്ടൻ്റ് ആയിട്ടുള്ള ഒരു ഡെറിവേഷൻ ആണ്. വളരെ ഇമ്പോർട്ടൻ്റ് ആയിട്ടുള്ള ഡെറിവേഷൻ ആണ്. പ്രൂവ് ദാറ്റ് ടോട്ടൽ മെക്കാനിക്കൽ എനർജി റിമെയിൻസ് കോൺസ്റ്റന്റ് വെൻ എ ബോഡി ഈസ് ഡ്രോപ്ഡ് ഫ്രം എ ഹൈറ്റ്. എല്ലാവരും എഴുതി എടുക്കണം, വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. മക്കളെ ഇത് വളരെ ഇമ്പോർട്ടൻ്റ് ആയിട്ടുള്ള ഒരു ഡെറിവേഷൻ ആണ്. എപ്പോഴും പരീക്ഷയ്ക്ക് ചോദിക്കുന്ന ക്വസ്റ്റ്യനാ. എപ്പോഴും പരീക്ഷയ്ക്ക് ചോദിക്കുന്ന ക്വസ്റ്റ്യനാ. എന്താ? ടോട്ടൽ മെക്കാനിക്കൽ എനർജി റിമെയിൻസ് കോൺസ്റ്റന്റ് വെൻ എ ബോഡി ഈസ് ഡ്രോപ്ഡ് ഫ്രം എ ഹൈറ്റ് h. അത് എപ്പോഴും റിപ്പീറ്റഡ് ക്വസ്റ്റ്യൻ ആണ്. എപ്പോഴും സ്കൂൾ എക്സാമുകൾക്ക് ഉണ്ടാവുന്ന ഒരു ക്വസ്റ്റ്യൻ ആണത്. നോട്ട് ചെയ്തോ? നോട്ട് ചെയ്യട്ടോ, വേഗം നോട്ട് ചെയ്യുക. എഴുതിയെടുക്കണം. ഡെറിവേഷൻ ആണ്, റിപ്പീറ്റഡ് ക്വസ്റ്റ്യൻ ആണ്. എഴുതിയെടുക്കുക തന്നെ വേണം. നോട്ട് ചെയ്ത് കഴിഞ്ഞാൽ പറയൂട്ടോ. നോട്ട് ഇടുന്ന ഇതേ നോട്ട് ചെയ്തോ? നെക്സ്റ്റ് കൺസർവേറ്റീവ് ആൻഡ് നോൺ കൺസർവേറ്റീവ് ഫോഴ്സ്. Next topic is conservative and non-conservative force. This topic is also very important. Conservative force എന്താണ്? If the work done by or against a force is independent of the path followed by the object, then the force is said to be conservative force. If the work done by or against the force is independent of the path, വർക്ക് ഡൺ പാത്തിനെ ഡിപ്പെൻഡ് ചെയ്യുന്നില്ല എങ്കിൽ ഇറ്റ് ഈസ് കോൾഡ് വാട്ട്? കൺസർവേറ്റീവ് ഫോഴ്സ്. Then the force is said to be conservative force. Example: electrostatic force, gravitational force. Explanation: work done by a conservative force does not depend on distance. Work done by conservative force does not depend on what? Distance, but it depends only on what? Displacement. Work done by a conservative force depends only on what? Displacement. Properties: work done for a round trip is zero. Work done for a round trip is zero. Why work done is zero? Because conservative force work done depends on what? Displacement. Round trip means what? The body is coming back to initial position. So what will be the displacement? Zero. Then what is the other property? The conservative forces are central forces. So it acts from center of one body to center of the other body. Example: Gravitational force that you will study in the 8th chapter. Next example, electrostatic force that you will study in the 12th standard. They are central forces. Work done by or against conservative force is completely recoverable. See, for example, I am placing this pen on top of my hand. I am lifting this pen upward. So I am doing a work. When I release my hand, what happens? That work done is completely recovered. So work done by or against conservative force is what? Completely recoverable. Please note that. What is meant by conservative force? What are the properties of conservative force? Note here. വളരെ ഇമ്പോർട്ടൻ്റ് ആയിട്ടുള്ള ഒരു ടോപ്പിക്കാണ് കൺസർവേറ്റീവ് ഫോഴ്സും അതിൻ്റെ പ്രോപ്പർട്ടീസും. റിപ്പീറ്റഡ് ആയിട്ട് കാണാവുന്ന ക്വസ്റ്റ്യൻ ആണ്. നോട്ട് ചെയ്യണം, എഴുതിയെടുക്കണം. വെറുതെ നോക്കിയിരുന്നോണ്ടായില്ല, എഴുതിയെടുക്കണം. Work done for a round trip is 0. Work done is what? Independent of path. Work done depends on what? Displacement. Then what? Work done is completely recoverable. These are the properties of conservative force. And what are the examples of conservative force? Electrostatic force and gravitational force. Electrostatic force and gravitational force are the done. All of it done, right? So next topic. What non-conservative force? So we have seen conservative force. Now we are going to discuss what? Non-conservative force. If the work done by or against the force depends on the path. Please do remember, in conservative force it was independent of path. Here it depends on the path followed by the object. Then the force is said to be non-conservative force. Example, frictional force and viscous force. Explanation. Work done by a conservative force, work done by a, here it should be work done by a non-conservative force depends on what? Distance. Work done by a conservative force depends on what? Displacement. Work done by a non-conservative force depends on what? Distance. Properties. Work done for a rounded trip is not 0. Work done for a rounded trip is what? Not 0. They are not central forces. They are not central forces. Work done by or against conservative force is not completely recoverable. Work done by or against non-conservative force is what? Not completely recoverable. Suppose ഞാൻ ചെരുപ്പിട്ട് കുറച്ച് ദൂരം ഇങ്ങോട്ട് നടന്നു. അപ്പോൾ ഫ്രിക്ഷൻ കാരണം കുറച്ച് വർക്ക് ഡൺ നടന്നു. അത് ഞാൻ തിരിച്ച് ആ ഇനീഷ്യൽ പോയിന്റിലോട്ട് മടങ്ങി വരുമ്പോൾ ആ വർക്ക് ഡൺ എനിക്ക് തിരിച്ച് കിട്ടുമോ? കിട്ടില്ല. പക്ഷെ കൺസർവേറ്റീവ് ഫോഴ്സിൽ എന്താ പ്രത്യേകത? വർക്ക് ഡൺ നമുക്ക് തിരിച്ച് കിട്ടും. ആണ് കൺസർവേറ്റീവ് ഫോഴ്സിന്റെ പ്രത്യേകത. ഡൗട്ടുണ്ടോ? നോട്ട് ചെയ്യടാ. നോൺ കൺസർവേറ്റീവ് ഫോഴ്സ്, ഇത് എപ്പോഴും പരീക്ഷയ്ക്ക് മാറി മാറി വരുന്നതാണ്. കൺസർവേറ്റീവ് ഫോഴ്സ് അതിന്റെ പ്രോപ്പർട്ടീസ്, നോൺ കൺസർവേറ്റീവ് ഫോഴ്സ് അതിന്റെ പ്രോപ്പർട്ടീസ്. അല്ലെങ്കിൽ give a comparative study between conservative forces and non conservative forces. Repeated question ആണ്. Kenya. All of you finish? So we were discussing conservative forces and non-conservative force. Next year, Albert Einstein mass energy equivalence. Suppose you are going for an interview and somebody asks you, what is physics? You can simply say E equal to mc square, which is the most important equation of physics. Albert Einstein showed that mass and energy are equivalent and are related by the equation E equal to mc square. Here c is what? Speed of light. Here c is what? Speed of light. C equal to 3 into 10 raised to 8 meter per second. The equation tells us that a very large amount of energy is associated with what? Small amount of mass. So from small amount of mass, we will get what? Large amount of energy. For example, calculate energy equivalent of 1 kilogram mass. How much energy we will get from 1 kilogram of mass? E equal to mc square. Mass is what? 1 kilogram. What is c? Speed of light? 3 into 10 raised to 8 the square. So what is energy? 9 into 10 raised to 16 joule. That much energy we will get from 1 kilogram mass. There is a NEET question. What is the energy equivalent of 1 nanogram? E equal to mc square. M equal to what? 1 nanogram or 10 raised to minus 9 gram. So mass is equal to 10 raised to minus 9 into 10 raised to minus 3. Many students will forget this step. Nano 10 raised to minus 9, okay. Nanogram has to be converted. So 10 raised to minus 9 into 10 raised to minus 3 kilogram. So what is mass? 10 raised to minus 12. So E equal to what? 10 raised to minus 12 into 3 into 10 raised to 8 the square. What is answer? E equal to 10 raised to minus 12 into 9 into 10 raised to 16. What is answer? 9 into 10 raised to plus 4 joule. This is the energy equivalent of 1 nanogram. Note here, please note down energy equivalent of 1 nanogram, energy equivalent of 1 kilogram. What is Albert Einstein mass energy relation? Energy and mass are interconvertible. Note here. So all of you, thank you. നന്നായി വായിച്ചോളൂ ഇന്നത്തെ ക്ലാസ്. നെക്സ്റ്റ് ക്ലാസ് ഈ ക്ലാസ്സിനെ ബേസ് ചെയ്തിട്ടുള്ള പ്രോബ്ലംസ് ആയിരിക്കും. ഇത് നന്നായി വായിച്ചാലേ അടുത്ത ക്ലാസ് മനസ്സിലാവുള്ളൂ. സോ താങ്ക് യു സ്റ്റുഡൻസ്, താങ്ക് യു.